Today we'll be talking about electric power. And consider a charge flowing through a battery where the potential difference between the battery terminals is V. We'd like to know how much power that will supply. We know that P is power, and we know that charge times voltage should be energy. Now, how do we know that? Well, we know that energy, this is energy, because it's charge times voltage. Well, what is charge measured in? Coulombs. What is voltage measured in? Joules per coulomb. So the two coulombs cancel out and you're left with joules. So the numerator of this equation is really just energy. The denominator of the equation is time. So when you think about it, the numerator is joules, the denominator is seconds, joule per second is watts. Okay, another way of looking at it is coulombs per unit of time can also be thought of as how much charge per unit of time is going through a surface. We know that as being current. So we can replace coulombs per time with I. So power is equal to IV, or current times voltage. Electric power. When there is current in a circuit as a result of a voltage, the electric power delivered to the circuit is power is equal to IV, and we just derived that equation in the previous slide. And we know the units for power are watts, or joules per second. And there's two other useful forms of this equation, and we'll derive them with the use of Ohm's law. The first is this. What we did is we took Ohm's law and we solved for V. We solved V for IR, and replaced that here, the V, with IR. So one form of the equation is power is equal to I squared R. Another form of the equation is, this time we're replacing current with V over R, because current is equal to V over R from Ohm's law. So we also have another form of the equation that it's equal to voltage squared over R. Okay, so let's try an example of this. In a flashlight, the current is 0.4 amps and the voltage is 3 volts. We'd like to find the power delivered to the bulb and the energy dissipated in the bulb in 5.5 minutes. Well, there's our little circuit, and let's try it. The power is pretty easy to figure out. Power is equal to current times voltage, or 0.4 amps times 3 volts, or 1.2 watts. And we also know that power is equal to energy per unit of time. So we could take that equation and solve for energy. Energy is equal to power times time. So we take the unit of watts, which is joules per second, and times it by how many seconds it occurred. 5.5 minutes is 330 seconds. And there we find out how much energy was actually used. Okay, now I'd like to talk to you about alternating current. In an AC circuit, or alternating current circuit, the charge flow reverses directions periodically. In the U.S., the typical voltage supplied by the power company to your house is 120 volts of alternating current, and it has a cycle of 60 hertz. So what does that actually mean? It means it goes from a positive to a negative voltage 60 times per second. Okay? And we're not going to really do any problems with this. It's not on the AP exam, but I just wanted you to be aware of it, that it was different from the direct current problems that we have in class.